In this video, we will go through the basics of set theory, set notations, and some of the foundations of set theory. A famous philosopher said, "I see the beauty of God's archetypal infinity reflected in the towers of infinities in set theory." Let's proceed. What is a set? A set is a collection of elements. Let's look at the set S here. S is a collection of two-dimensional shapes. T is a set of three-dimensional shapes. And you have a set here, which is a collection of people. You have a set here, which is a collection of things, objects. And you have a set here, which is a collection of numbers. So set theory is basically dealing with sets which can be defined as collection of elements. And it always starts with an open parenthesis and closes with a closed parenthesis. Let's look at some of the basic notations that we use in set theory. Consider a set U, which comprises of set A, set B, and set C. Let's say set A is a box of chocolates, and set B is cupcakes, and set C is a set of ice cream cones. Right. U is called the universal set because it carries all the elements of set A, B, and C. So it's normally written as U, and it's mostly called the basic set. Next, its notation belongs to refers to if I have a set A and it belongs to the set U, then I can write it as A belongs to U. And this notation is used for subset. So let's take this subset B, which is the set B, and B has some of the elements of U. So B can be called a subset of U, and it's written in this form. And since U has all the elements of B and plus it's got all the elements of others, U is called a superset. Now B can be called a proper subset if it does not have all the elements of U. If B has all the chocolates, cupcakes, and cones, then B cannot be a proper subset. But B has only cupcakes, which is part of U. So B is called a proper subset of U. Next, let's see what is equal sets. Let's consider two sets A and a set T. And set A is a box of chocolates, and set D is another typical box of chocolates. So A can be called a subset of D because A has all the elements of D, or I can say D has all the elements of A. And D is a subset of A because A has all the elements of D. So if we can write A and D interchangeably as subset to each other, then A and D are equal sets. And we can also express A as an improper subset of D. Why did he say that? We saw on the last slide that if A will have all the elements of D, then it is a subset, but it is not a proper subset. So we can call it an improper subset. Next, we're going to see what are trivial subsets. Right. Let's consider again the box of chocolates, which is set A. Now, A can be called a subset to itself, which is A is a subset of A. And in set theory, all pi, which is an empty set, the set comprises of no elements, is a subset of A. So these two sets, which is pi, which is an empty set, and the set A, which has all the elements of A, are both called the trivial subsets of the set A. Next, we're going to see what is union. Again, let's consider the same example of a universal set with the set A as chocolates and set B as cupcakes and set C as ice cream cones. Now let's take these two sets A and B and let's club all the items together and put them together. So when you put all the items of an A and B together, it is called A union B. And this is a symbol for union. And in set theory, we can write it as A union B is equal to set of X such that X belongs to A or X belongs to B. So kindly note, I put a R, which means it should belong, X should belong to A or X can belong to B. So all the elements will be put together. Next, let's see what is intersection. So let's consider the set A with ice cream cones and set B with ice cream cones. You can see this particular, I think it's butterscotch, is not in B, and the chocolate ice cream that you see here is not in A, whereas these two ice creams are in both A and B. So the common ice creams are these two, and this set of these two ice creams is called A intersection B, and this is a symbol that we use for it. So A intersection B can be written as a set of X such that X belongs to A and X belongs to B. So note the difference. Here we say and. What is disjoint set? Let's look at these two sets. Set A has a box of chocolates and set S that has shapes. Is there anything common between these two sets? No, there's nothing. So these two sets have nothing. If you say A intersection S, then it's an empty set. So as such, a set A and S, when its intersection is empty set, then A and S are called disjoint sets. Next, let's see what is complement to a set. Set A is a set of chocolates, and if I say A dash or A complement, what I mean is all the elements that are in U except the ones that are in A, which means I will remove the elements of A from U and put B and C together and make a set. So that is a complement set. So A complement can be written as X such that X belongs to U, and X does not belong to A. Let's see what is set difference. We have two sets, set A that has 4 ice cream cones and set B which has 3 ice cream cones. You can see that these 3 ice cream cones are common to both the sets, whereas the butterscotch is standing alone in set A and not being common to B. So when you subtract B from A, you will eliminate these 3 ice cream cones and you will end up with just this one ice cream cone, right? So that's called a set difference. So you can define set difference as A minus B is equal to set A, where A belongs to A and A does not belong to B. Next, let's see what is a finite set. A finite set is a set that comprises of finite number of elements. Set of A, which is alphabets, we know the number of alphabets, so it's a finite number. So set A has a finite number, so it is called a finite set. So we can define it by saying A has K elements and K belongs to W, which is set of whole numbers. So K is a finite number and A has K elements, which is finite number of elements. So A is a finite set. Next, let's see what is infinite set. Any set that has infinite number of elements is called an infinite set. So the set of whole numbers, which starts from 0 and goes all the way to infinity, is a set of infinite set, right? Next, let's see what is a singleton set. A singleton set is a set that has only one element. So when I write the notation n of p, p is a set. N of p means the number of elements that are in the set p. So if the number of elements in p is equal to only 1, then this set p is called a singleton set. Cardinality of a set. Consider the set A with 4 elements. So the number of elements n of A can be written as 4. So what can we say? We can say the set A has cardinality of 4, right? So if n of A is equal to k, then we can say the set has cardinality of k. Next, let's see what is symmetric difference between two sets. Set A and set B are shown here using the Venn diagram, and A union B would be 10, 5, 25, and 31. So we have them here. And A intersection B would be the common elements, which are 5 and 25. Right, so we have them here. So if we find the difference between the union and the intersection, so if I say A union B minus A intersection B, then what do we get? We eliminate these two elements from here. So you'll be left with 10 and 31. So we take away what is common and we just put the ones which are not common. And that is called a symmetric difference between the two sets. What is a power set? Consider set A, which has elements 1, 2, and 3. A power set is a set of all subsets of A. So let's express power set as P of A. And it starts with a big open parenthesis. And then you put in all the subsets of A. So we will start with an empty set. We know that empty set is a subset of A. Then 1 is a subset of A, 2 will be a subset of A, 3 will be a subset of A, 1, 2 will be a subset of A, 1, 3 will be a subset of A, 2, 3 will be a subset of A, then 1, 2, 3 will also be a subset of A. So this set P, which comprises of all the subsets of A, is called the power set. Now we can define power set as power set of A is equal to set of all B's where B is a subset of A. Now the number of elements of this power set is 2 power n, where n is the number of elements of the set A. Now I want to take you through some of the basic notations for numbers. I'm sure that you're familiar with this, but let's just recap. So natural numbers are nothing but counting numbers from 1 all the way to infinity, so it's in one direction and it's expressed as n. Whole numbers are counting numbers and 0, so it starts from 0 and goes from 1, 2, 3, and also in one direction, and it's expressed as w. Integers are whole numbers and their opposites. So whole numbers we know are 0, 1, 2, 3, and their opposites are minus 1, minus 2, minus 3, and it goes to infinity. So you have infinity on both directions, and it's expressed as z. Rational numbers are numbers that can be expressed in the form of a by b in a fraction form, where b is not equal to 0, and these numbers are expressed as q. Irrational numbers are numbers that cannot be written as rational numbers, which is you cannot write a over b and express them. So you have these examples here. So they will have recurring decimals. So these numbers are called irrational numbers, and they're expressed as I. And real numbers are both rational and irrational, all the numbers put together. It's called real numbers, and we express it as R. Thank you for watching Math Tutorial Anand. Please like, and you can comment if you have any questions, and do not forget to subscribe to get more videos like this.